In this video, we briefly introduce the broadband dual-polarized filtering metasurface-based antennas using characteristic mode analysis for 5G millimeter wave applications. The reference work can be found in IEEE transactions on antennas and propagation. For the millimeter wave filtering antenna, it has big challenge to utilize novel design method to realize broadband, high suppression and wide stopband features. The characteristic mode analysis is a novel method to provide the guidance of designing filtering antenna. By using CMA, the modal behaviors of the metasurface structure can be analyzed to generate multiple resonance frequencies and radiation nulls simultaneously. Based on resonance frequencies and radiation nulls, one high suppression filtering antenna, antenna A, with an out-of-band suppression level about 30 dB and one wide stopband filtering antenna, antenna B, with a stop suppression range about 2.15 F0 are realized. Characteristic mode analysis is performed on the simple 2x2 uniformly distributed square metasurface structure. To realize filtering antennas, modes J1 and J2 are chosen as the in-band resonance modes and mode J7 and J8 are chosen as out-of-band nulls respectively. By adopting different slot coupling methods, the desired modes of the metasurface structure can be excited to realize good filtering features. As can be seen, the proposed antenna A is mainly composed of a metasurface structure with L-shaped slots, the stubs, the metal ground etched with a long slot and two striplets. Resonance frequencies FR1 FR3 are introduced by slot, mode J1 of metasurface and stub and radiation nulls FN1 FN3 are introduced by mode J7 of metasurface, stub and L-shaped slot. Finally, out-of-band suppression level of the upper stop band is up to 30 dB and great filtering characteristic is performed. Antenna B is formed by rotating the metasurface structure and the stubs of antenna A by 45 degrees to realize the wide upper stop band. It can be found that the positions between the metasurface and coupling slot would affect the CMA modes and filtering features. For the antenna A, radiation mode of J4 appears at 38 GHz and deteriorates suppression level of upper stop band. By rotating the metasurface structure and the stubs by 45 degrees, there are no radiation modes appearing during 32-58 GHz for the antenna B. Finally, for measurement, the size of the ground is enlarged, which would generate radiation mode at the upper stop band and then worsen the out-of-band suppression. In order to eliminate the impact of the GND, DGSH GND is adopted to avoid radiation mode. For the antenna B adapting large full GND, radiation mode J4 appears at 50 GHz and generate radiation in the broadside direction. By replacing the large full GND with DGS GND, radiation mode J4 at 50 GHz is disappeared. More details of the work can be found in the reference. Thank you for your attention.